Alright, section 4.4, example 3, gives us a little bit different equation because they're throwing an absolute value into a logarithm. So that'll be interesting to see what that does. And it's not going to follow all the same rules and properties that we've been getting used to, although I expect we'll see some similarities. Alright, let's go ahead and start with finding domain. So again, our argument has to be greater than 0. So let's take our absolute value of x minus 1 and set that greater than 0. Well, the cool thing is the absolute value is always a positive number or 0, and so that is always going to be a positive number unless it equals 0. So the only thing we need to worry about at all is just if we have a value that makes this equal 0. So that would be a positive 1, correct? So that means x minus 1 cannot equal 0, and therefore x cannot equal 1. So that is our domain, and that will also determine our asymptote, where the graph cannot exist. Okay, next let's go ahead and look at intercepts. So for our x-intercept, we just take our function and set it equal to 0 and solve it. So to do that, we remember the base of our logarithm is 10, because we're going to change this to exponential form. 10 to the 0 power equals the absolute value of x minus 1. There it is. So now 10 to the 0 power is 1, and so 1 equals the absolute value of x minus 1. I don't know if you remember how to solve absolute value equations, but the absolute value means we have two different possibilities, because we could have the possibility where the inside stuff is positive, and we get a positive 1, or the possibility where the inside stuff is negative, to give us that positive 1. So in order to account for both possibilities, we get rid of the absolute value and write it out as two separate problems. So we can either have x minus 1 equals a positive 1, or we could have x minus 1 equals a negative 1, because that would mean that the inside stuff adds up to a negative 1, which would give us the absolute value of negative 1 is 1. Okay? So either way, let's go ahead and solve it. We could add the 1 to each side, so we would have x equals 2, or we can add that 1 to each side, and we would have x equals 0. So that gives us x-intercepts at 2 and 0. Alright, so then what about y-intercept? Well, the fact is, if you have an x-intercept at 0, 0, that also is a y-intercept. And if this is really a function, you're only going to have one y-intercept. But let's just check it just in case. So again, yeah, those are our x-intercepts. So for our y-intercept, we're going to plug a 0 in place of x. So 0 minus 1 equals the log of 1, because it would be the log of the absolute value of negative 1, or the log of 1. So that's base 10, log base 10 of 1. It doesn't matter what the base is, because anytime you take the log of 1, the answer is 0, because anything to the 0 power is 1. So that right there confirms that our y-intercept is at 0, 0, which we already knew because we had an x-intercept there. Okay, transformations are a little harder on this just because it's kind of a strange problem, but we still have this obvious inside piece that's going that's x minus 1, which kind of indicates we have a transformation to the right 1, don't you agree? So we're going to have that asymptote instead of at 0, it's going to be at right 1. Okay, let's go ahead and plug in some additional points so we can see what this is going to look like. Make a t-chart here. I'm going to choose x values that give me pretty y values. So since we're dealing with log base 10, it would be good to have values of 10 maybe in here. So to get a negative 10, which would absolute value be positive 10, we could use a negative 9. So negative 9 minus 1 is negative 10, and the absolute value of negative 10 is 10, and log base 10 of 10 is 1. Another good option would be 11. 11 minus 1 is 10. So then the log base 10 of 10 is 1. So in case you didn't understand what I was saying, there's the work for that process to find those 2 points. Okay, last we've kind of already talked about asymptote. X can't equal 1, and the transformation is shifting to the right 1. That all points to the asymptote, which is going to be at x equals 1. let's go ahead and take everything we know and put it on our picture. So we've got our x-intercepts at 0, 0, and 2, 0. We've got a point at negative 9, 1. We've got a point at positive 11, 1. And then we could plug in other points, but that would just keep going. Like if we did, so we could get 100 in here, like a negative 99, then that would be 2, because 10 to the second power is 10, right? So that would just be slowly climbing upward in each direction. We could also plug in some points here to see what our graph is doing, but I feel pretty confident that if we have an asymptote at 1, that we know our graph is going to approach that asymptote, because remember, graphs never cross a vertical asymptote. So let's see what this graph might look like, something like this, and there we go. Kind of an unusual logarithm graph containing an absolute value, still has a vertical asymptote, and we still had to understand how logarithms work to plug in some points and find our intercepts and solve and all that. So good little practice of putting some of the things together that we've been learning.